Yeah, good morning together. Nice to see you all here. Hope everyone has your coffee or had your coffee or tea or whatever you need to be awake. It's early in the morning. As Roman already said, yeah, the only one AI-related presentation for this conference. I'm a bit surprised. I hope it's not the hype is not already over. So I hope you're still interested in this topic. I try to combine two hot topics. One is edge delivery and document-based authoring, and the other, on the other side, it's AI. Of course, not doing the obvious thing like creating content with the AI, creating text or images, but enhancing or the search experience in an edge delivery AEM setup. So AI-powered search with AEM Sites and our chatbot technology. I'm coming later to this. First, I'm Tino Truppel, Managing Director at Büro am Draht. Yeah, my main topics are, or focus are identity access management and digital experience platforms. We are Adobe solution partner, and yeah, and I love to create scalable infrastructure solutions for our customers. So what is the motivation of my presentation today? We learned a lot about edge delivery and document-based authoring the last 2 days, and it's quite the same motivation. So in former days, or in classic CMS approaches, yeah, it's a very time-consuming process to change content. Often you have to create tickets. If you are the content creator, you're not working directly with the CMS, you're creating tickets and someone is changing the content. It needs time. It needs time to migrate to this CMS, enterprise-based CMS. And more often, it's really heavily relying on the fly caching. That means the first visitor, the first guy, the first girl hitting the page is the poor person for this. The page is rendered and the cache is created. Most of the time it works, but if you have a huge page like a web shop with millions of products and like a very long tail, and if you have lots of visitors or lots of changes like price changes, feedback on the product detail page, for example, then the hit cache ratio is very low. So new approach, and we discussed this the last days, is the edge delivery approach, pre-rendering with semantic HTML, the content of the pages, and using pure front-end code to design, to rearrange, to change the components of the page. And that needs very high performance, 100 Lighthouse score. That's the goal, and that's like default. You have really put effort into it to be slower. And yeah, this is at least what the advertisement said, migration within 2 weeks to this new platform. Okay, maybe in reality it's like 3 or 4 weeks, but it's much faster. And for the authoring part, it's also much simpler because it's very clear what one page is. One page is one component, one page is one document, one data source is one Excel file. And actually, you want to have the very same benefits for the search as well. Like simple setup. The search should not be like deployment, development, setup, installation, and it should be like configuration. Click and configure it, and it should work. It should be affordable. Yeah, no expensive cloud infrastructure should be required, like not a huge ElasticSearch stack. So you have your edge delivery website very low in cost and on runtime, and on the other hand, when you have ElasticSearch, it should not like a best practice pattern. And for the authoring part, it should be transparent. So it should be transparent. So for the authors, for the editors, what is actually what the search is doing, what is in the index, what are the keywords, so that you can maybe change it, can manage it without having like technical insights. Also, as said, transparency to be able to edit the index file, like in an Excel file or Google spreadsheet, and optimize performance so that you have like most of the parts of the search experience rendered and compute on the front-end side in the browser. What is the common or the approach nowadays in AEM Franklin in Edge Delivery is, load the whole query index or almost the whole query index into the browser. I don't know where this screenshot coming from, but for example, here this query index is like 100 kilobytes. And then doing kind of magic regex about this index file over the title and the description. And of course, the title and description is manually entered by the author, so it contains lots of fill words and or he, she, whatever. That's not used or not valuable for the search. That's why we suggest we try to in a proof of concept another approach, and this is like, why not enhancing the index file on publish? So you click on publish, extracting the content by using large language model, and not putting like the title and description in an index file, but asking the large language model, what are the keywords? What are the search terms someone would try to search for this page, for this article, and putting this result of this large language model into the index file. We're using for this, on one hand, we use Edge Delivery, and on the other hand, we're using our chatbot tool called Chatbottery. I think almost every company has their own chatbot tool, so we have our own as well. The good thing is here, it's totally front-end rendered. The whole dialogue, the whole magic is in the front-end, JavaScript-based, and this is very compatible to Edge Delivery, actually. And that's why it fits very well together. And this for the beginning, and want to now continue with the demo, and then we look into how it actually works. And sorry, I hope you can bear with me. The issue is that I'm not having the screen mirrored here on this screen, so I have to look like this, and I hope I'm able to do this. The demo page we created is the blog page of Chatbottery. Chatbottery is our chatbot tool, as said, and it's quite common blog page. Nothing too fancy here. If you look more deeper into the content, you will see that's AI-generated content mainly, but so it's more like a sandbox, more like a testing page. So it's a AEM Edge Delivery-based page. With recent posts, you can go into this. Go into the post, can read it, and you can search. You can search, for example, here, and this is the chatbot, which journey, and then you get results. So not so much about Midjourney on this chatbot on this page here, but in a second we are going to change this so you understand how this works. In the authoring part, it's not so much surprising. We're using Google Workspace here, so I'm pretty sure you know this, how it looks like, the main folder with the index file, footer, and so on, a query index, and here are the posts. All the posts we have already here, it's not so much, to be honest, and the search page. So the search page, it's like if you click on the small classes in the top corner, then you get this page, and this page is just one component, one block, our Chatbottery block. And this is use the, I'm coming to this later. So, and what you actually want to do is to change, let's go here, change this this article here. So this article is just about how image can be generated through AI. As said, do not read this whole article, it's AI generated. So, of course, you can imagine how this works. We're going here and no, I'm lost, to be honest. Where is it? Good preparation. Sorry, okay. However, then I'm going to change this article. Sorry, and I already prepared a text. I asked ChatGPT to change the content of a current article and add a Midjourney and DALL-E 2 comparison into this article. So, as I've seen in my search before, there was not so many Midjourney search results, but we are going to change this. So, just copy and paste. Here, the new input with DALL-E 2 and Midjourney. Generating the preview. And publishing it. So what's happening right now is, of course, the Markdown is rendered and it's published to the live page. But meanwhile, a hook is generated to our GitHub Actions. And this GitHub Actions starts getting the content of the published pages, or getting the content of the published page, and asks ChatGPT, hey, can you sum up this this content? While we're waiting for this status here, I can show you how this works. Here in do I have a diagram here? What's happening right now is, so we first publish the document and then trigger the GitHub Action pipeline. The GitHub Action pipeline takes the HTML, the rendered HTML from the public page, goes to a GPT-4 API, asks GPT-4, can you generate keywords for this content? I will show you the prompt just in a second. And then the result of this prompt of this query to GPT-4 is then added to the chatbot index file. And this chatbot index file is just an Excel Google spreadsheet we are using as an index file for the search. And then this is loaded on runtime in the search page, this Google spreadsheet. The prompt looks like that. So, or the action, the GitHub action looks like this. The content is loaded, the Markdown file from the page URL, and then an ID is generated for this page URL, because if you change the URL, so the URL is not the identifier of the page, we have our own ID, and then the content is extract from the page, from the Markdown page, and then ChatGPT is asked with this content. And how we ask ChatGPT or GPT-4 API. We created a prompt. So this prompt actually was created with ChatGPT as well. We asked ChatGPT, how would you ask yourself to sum up a page for a search index? So and the main trick here is to say, okay, whatever you analyze, return this in a valid JSON, and in the provided language. So like in the language, the content of the page is itself. So that makes the search index in the same language like the page was before. So and this is the valid JSON here. So like title, author, URL, and the phrase. at least 10 search phrases that a user could enter to find this page, each enclosed with quotation marks. And yeah, this works very well. So this results in in somehow 99% in the cases in valid JSON, and this can then be added to our Google spreadsheet. So let's see here. Here's our data, our Chatbottery data, and it was changed 9/16. So this was just recently. That means this job was done. Yeah. So what took 1 minute? We can look into it. How was it done? So here you see. I think here runs script, the Scala script, and here's the response of ChatGPT of the GPT API, and this response was then added here. I think here it was added here, and then we have here further generate AI. This is the main keyword, and then you have further keywords here, and then it is extracted Midjourney and DALL-E 2 as one of the main keywords. What we're not doing right now is we are not publishing this spreadsheet. This is still a manual step because it's still work in progress, but it's just a little enhancement also to use the GitHub action to publish this spreadsheet. So I'm now doing this manually, publishing this spreadsheet, and then I hope that sorry, I think after this I have hurt my neck. Sorry. And maybe to avoid some caching, disable cache. Okay, reload. And now if I use search for Midjourney, so we have more hits now. This was the first hit we had before, and this is a new hit. I didn't change the title, but if I go here, then I have here the description of the new created article, or of the change article. You see with Midjourney and DALL-E 2, and if I go here into this article, then is here the changed content with DALL-E 2 and Midjourney comparison. So far, what we have done. So I've showed you this. You can test this by your own. In the we have the blogs, the Chatbottery blogs, and the GitHub actions available in public GitHub repository. And yeah, in the end of my presentation, I want to discuss. Maybe you're wondering, yeah, why not using a large language model directly, in an LLM directly? So why not feeding the content of the change website directly into a large language model, for example, through fine-tuning and whatever, and then querying this large language model directly. And you may be right, because there are reasons or there are arguments to do so. Yeah. So if you imagine you would a changed website pushed into a large language model, set, for example, through fine-tuning, then you have like a model where you can talk, you can have a conversation about your whole website. Yeah, you can query it. It will understand you. It will understand you in every kind of language. It will even if you make typos or spelling errors, it will understand the user. The indexing is much more intelligent. It will understand even semantically what's in the content, and of course then it can be order the results easily by relevance or ranking, and it can easily sum up content or of the website. So if you ask something, it can sum up, and it can sum up the content in your language, in German or English or whatever language, but even in your kind of wording. So if you, depending on your target group, for example, the result or the answer could be summarized regarding your target group. And yeah, lots of benefits if you would do this like this. And in my opinion, our opinion, it's, maybe this will be the future, but not right now. Maybe in 6 months, 12 months, or whatever, because technology is evolving. Right now, we see too many drawbacks. We have like the computational cost. It will take time. Even if you do it on runtime, if it's seconds, it will be longer. It will take longer than just what you have seen, like just typing and you get instantly the result. It costs money, of course. Every kind of request, so like the requests we have seen here in a GitHub action, it's around 10 cents. It's not that much because it's only on publish. But imagine if you would do this kind of cost every time someone is using the search. It's more complex, so it's like a black box for the author. So the author cannot see what actually is in this large language model. It cannot manage it, cannot change it. It's not visible for the author of the website. Of course, you have like data privacy issues, this kind of discussion, and of course, you have risk that that it starts to hallucinate, return things that's not on your website, just thinking, hallucinate over things, and I said, and there's a missing transparency for the authors. All these things are, I think, are addressed in the technology we have here, but they are not solved right now. So, to sum up, what I've shown you is like an approach how to use right now existing large language models without fine-tuning, without creating your own model, or use case where you can use a large language model like GPT-4 or whatever other kind of large language model right now without any kind of privacy or ethical concerns, because it's not used on runtime. It's used to enhance content, transparent to the editor. So the editor sees what the AI is generating and can change it, can edit it if it's wrong. And I think it helps very much because it enhanced the index. Of course, it's not a full-blown ElasticSearch right now, but I think it's a huge step forward regarding the current approach in AEM Franklin, how to implement the search right now. Okay, with this in mind, thank you very much. If you have any questions or feedback, I'm really looking into your comments. Thank you. Sorry, maybe I was a bit too fast.
Way too fast, so. Yeah, question round. Somebody would like to know how well it behaves or like searches in natural language or with a synonym search.
Quite well if the synonyms are found in the keywords. Of course, like the Excel search is done like regex in over this JSON file, and there are some similarity search already implemented in this regex in the Chatbottery logic, but of course the synonyms are missed right now. So of course, you could ask in the prompt to put synonyms of the keywords. So we haven't done this right now, but it could be a good improvement just asking GPT-4 by generating the index also put in synonyms into the keyword list.
All right. So did you use it like already somewhere in production, like this constellation, or just like on?
No, it's like a proof of concept.
All right. Great. Thank you, Timo.
Thank you very much.